Backpropagation through time TERT and its mechanism. Backpropagation through time TERT is a specialized version of the backpropagation algorithm designed for training recurrent neural networks, unlike feedforward neural networks, which process inputs independently and maintain temporal dependencies, meaning their outputs depend on past states. This temporal nature prevents the direct application of standard backpropagation, requiring a modified approach like TERT to properly adjust network parameters. The process of TERT begins with unrolling the URN along the time axis, transforming it into a feedforward-like structure. Since URNs reuse the same weights, at each time step unrolling allows the model to be treated as a deep neural network with shared parameters across layers. Once unrolled, the input sequence is processed through the network, computing hidden states and outputs at each time step. The loss is then calculated at the final output layer, providing a measure of error that needs to be minimized. During backpropagation, the error is propagated backward through time, allowing each time step parameters to be updated based on its contribution to the overall loss. This backward pass ensures that all time-dependent weights receive appropriate adjustments. Finally, the network parameters are updated using optimization techniques such as stochastic gradient descent or other gradient-based methods, improving the network ability to model sequential dependencies. One major challenge of TERT is the vanishing gradient problem. As the sequence lengths increase, as the gradients used for weight updates become exponentially smaller, making it difficult for the network to learn long-term dependencies. To address this, specialized architectures such as long short-term memory and gated recurrent unit neural networks have been developed, incorporating mechanisms that help retain information over extended sequences. Another issue with TERT is its high computational cost, as unrolling the entire sequence requires extensive memory and processing power. A common solution is truncated TERT, which limits backpropagation to a fixed number of time steps rather than the entire sequence, significantly reducing computational complexity while maintaining effective learning. TERT remains a fundamental technique in training grounds, playing a crucial role in applications such as time series analysis, natural language processing, pulp, and other tasks involving sequential data. By efficiently handling temporal dependencies, TERT allows neural networks to learn from past information, making it an essential tool in deep learning for sequential data processing.